In this lesson, we're going to look at ordered pairs and their relations. We're going to look at how we sometimes name those pairs, those pair groups, and we'll talk about using the coordinate plane. Here is an example of ordered pairs. So when we talk about an ordered pair, we're talking about something like this. If we were looking at bungee jumpers, we could say, all right, we have one part of our graph that's going to be the height, and one part of our graph that's going to be the fall time. And we would have a line. If we looked at all of these different places, we would end up with some kind of a line made up of those ordered pairs. So when we talk about ordered pairs, we are talking about something very specific. And part of the idea of ordered pairs is to create a system where anyone who looks at a particular point on a coordinate plane, that's what this is, it's part of a coordinate plane, anyone who looks at a specific point would give it the same number. So if we come down to this number, 4, 5, the 4 is always what we're seeing on the x-axis, the first number, and the second number, in this case the 5, is always what we're seeing on the y-axis, right here. And the 0.45 could be specifically graphed by going to 4 on the x-axis, 5 on the y-axis, and labeling a point. And anyone who was given the 0.45 to place on a coordinate plane would place it in exactly the same spot, because that's how the system works. It's very similar in geography. You haven't gotten there yet, or maybe you did actually before 7th grade. But you will see geography that talks about latitude and longitude. Latitude and longitude is basically a coordinate plane laid out on the Earth so that anybody giving a specific latitude and longitude location can pinpoint a spot, and anybody else having that same latitude and longitude location would pinpoint the very same spot. So that is the basic idea behind ordered pairs. We'll take a look at the next page and get some more information. So let's go ahead and take a look at some ordered pair problems and how we graph them on a coordinate plane. So you start at the origin. The origin is always the 0, 0 point. So the label of the origin is 0, 0. No x's, no y's. You always count the x's first, so you move either right or left, right if it's positive x, left if it's negative x, and then you count the y, up if it's positive y, down if it's negative y, and then you place the point. So that shows the placement of point J, and if we look down in example B, shows the placement of K. So go ahead, use your graph paper to do those 4 got it problems. Lay out a graph, lay them all out on the same graph. They are all positive values, both x and y, so you'll lay them out in a graph like this. Here's a note, quick note to make in your spiral. Just draw an x and a y. Go ahead, there's the x, there's the y. Remember the advantage of the video, if I go a little quickly, you can go ahead and stop at any time. Those are the opposites of y, or what you might think of as negatives. These are the opposites of x. Having a hard time drawing here for some reason. What we might think of as negative x's. And whenever we label the quadrants, we label them the following. That's quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Notice quadrant 1 has values. All the values in quadrant 1 are positive values. The x's are positive and the y values are positive. If you move into quadrant 2, the x values, the first value you see, are negative and the y values are positive. If you move over into quadrant 3, both the x and the y values are negatives. Looks like somebody's sleeping. There's their nose. And finally, if you move into quadrant 4 now, the x values are positive and the y values are negative. Since all of these are positives, you will only need to draw quadrant 1. So pause the video now, draw yourself a quadrant 1 graph, and do those 4 got it problems. Okay, so you've had a chance to do those. I'm going to put the answer up on the screen so you can check your work. Again, pause the video, give yourself a chance to check. And if you made any mistakes, put them in the correct spot with your red pen and the letter with your red pen so that you remind yourself of what you made the mistake, what didn't work right the last time. All right, so you can see from examples A and B how they counted. For A, started at the origin, over 2, up 6, gives it a coordinate of 2, 6. B is a unique situation where the point actually lies on the x-axis. So they went 3 over on the x-axis, but they didn't go up or down on the y-axis, and so it's going to have a value of 3, 0. So pause the video and find the values for C and D. So for C, you can see that it doesn't go left or right on the x-axis. It's right above the origin. So that means its x value is 0 and its y value is 2. So it would have a value of 0, 2. For D, over 1, 2, 3, 4, 5, 6 on the x-axis. So the first value would be a 6. Having a little bit of pen issue. Come on, pen. There we go. And up 1, 2, 3, it's going to have a value of 6, 3. So look at those again. If there's anything you need to review there, review. And we are going to move on to the next page. But again, you have the total control of the video. You can pause at any point that you want to. So the next set shows us a couple of the fundamental ideas here. There are 3 big things in this example, or in this discussion. There's the idea of a relation, the idea of a domain, and the idea of a range. So this set of ordered pairs, 2, 3, 3, 5, and 4, 1, is a relation. A relation can be shown with a table, it can be shown with a graph. The domain of the relation is the set of all the x coordinates. So if you're looking at all the x values in this table, they make up the domain. On the other hand, all the y values make up the range. Go ahead and put those examples into your spiral now, the idea of domain and the idea of range. So once you have that written in, take a look at example 3. Express the relation as a table. So you would put these into a table. So 0, 2, 1, 4, 2, 5, there's the 2, 5, and 3, 8. Then determine the domain and the range. The domain are all the values here on the x. I used blue before, so let me use blue again. And the range are all the values here on the y. So go ahead, got it, problem 3. Build a table out of this relation and then identify the domain and the range. Go ahead, pause the video, do that, come back and check your work. All right, so you had a chance to check your answer on that. Let's look at one more example and then you can try some work. So here's the seahorse. It swims at a rate of about 5 feet per hour. Make a table of ordered pairs so we can see that 1 hour, 5 feet, 2 hours, 10 feet, 4 hours, 20 feet. Go ahead and describe that with a graph. So you've got your graph paper there, your coordinate plane. You can see that laid out. And then answer the question, how does that graph look? It appears to be a line from what we can tell. And it is. It's a direct relationship of time to distance. So read got it problem number 4 and make a table, graph the ordered pairs, and then describe the graph. Here's your opportunity for some practice. Go ahead and pause the video, use the video to do the guided practice, or you can go into the site through your Chromebook and Connect Ed, pull up the page, do the practice, and then finish with the video, and I've left you all the guided practice answers. If you get all that done and you're ready to move on, you can begin tonight's homework. Remember, you have the quiz due tomorrow. It's a formative quiz, which means it's not graded. We'll go through and discuss the answers. It's an opportunity to get knowledge on the things you don't understand yet, because we do have a test coming up soon. We're almost at the end of the first chapter.